Welcome and thanks for joining us. My guests today are Brandon Gulla. He is the Vice President and Chief Technology Officer at Rancher Government Solutions, and Adam Toy is the Chief Architect for Rancher Government Solutions. Gentlemen, good to have you both with us this morning.
Absolutely. Thanks for having us back.
And let's talk about this whole idea of supply chain security. It's a big issue technically and also policy-wise for government. And it's kind of hard to separate it from cloud adoption and from all of the modernizing that is going on in the federal government. These things are kind of all of a piece. So the challenges in modernizing relative to what it is people need to think about in software supply chain. Brandon, what's going on?
Yeah, great question. So when it comes to cloud adoption and IT modernization in general, commonly there's three main practices that need to be addressed: speed, scalability, and security. Cloud gives us a lot of opportunity in the scalability, of course, of the speed, but security always comes last in these equations. And we've seen the government hype cycle and adoption rate of cloud start to mature. Now security is, properly coming into the consideration more than ever. And that's being driven not just by the government capabilities, but commercially, we've seen a lot of unfortunate headlines in the news when it comes for Log4j, or maybe the SolarWinds breach of a few years ago, and breaches throughout the corporate infrastructure. We've seen, while that happens in the commercial industry, we know it's just as much a threat within the US government and their supporting partners as well. So we, as a software vendor here at Rancher, want to continue to fortify that baseline and provide scalable security solutions for our customers, both at the asset level, but that, actual implementations that they can take advantage of and bring into their software packages as well.
And so this all should really happen way before software is deployed, but this relates to the development process and the scrums and the iterations that people are doing?
Yeah, 100%. So we've seen DevOps and DevSecOps as the idea of pushing left, pulling everyone a little bit closer to the action and making it an iteratable development experience. Unfortunately, we've seen our adversaries and attackers do the same thing. And while they are fortifying their attack methodologies, they're also shifting left towards the actual creation supply chain of the software. Unfortunately, that's because that type of attack actually scales. If you can get in and provide a vulnerability within the actual product itself, you don't have to attack one by one. You have an open door for the entire user space. So naturally, they want to move into that component. So it's important for us to provide all the binary assets and in honesty, transparency and observability to what's actually running in that underlying software component. And it's up to us as a software vendor and software vendors around the world to make that information available to their end customers and users alike.
And what about the idea of just keeping it all abstracted and simple for those development teams? Because sometimes if a security regime and a security programming regime gets too complex, they can kind of go away from their own weight.
Yeah, absolutely. I mean, death by security, right? So we see that as paramount. So what we've done here at Ranchers, I'm happy to announce that we've actually taken a bunch of new approaches to our security methodologies for our federal customers and baked it into an umbrella project that we've called Rancher Carbide. And Carbide is essentially our differentiated distribution of the Rancher portfolio specifically for our government partners. We've seen time and time again that our customers demand more security regulations and compliance artifacts that are specific to its mission and its enterprise platform tools. So I'll go into everything that Carbide is composed of here in a moment. But in reality, we want to bring that security to a government consumable fashion with that click of a button or turn of a key. We know that assessors and AOs throughout the US government, while they've just now come up to speed with cloud native technologies, we can't continue to make it harder on them to consume and assess the vulnerability states of their underlying software artifacts. We have to meet them halfway or even further. And that's what we're doing with Rancher Carbide. So Adam, do you want to kind of go into some of the components that we've built into Carbide that differentiate it from upstream?
Absolutely. Thank you, Brandon. So one of the key security aspects currently in the ecosystem in the industry is securing the software supply chain. And one of the major components of Carbide itself is known as the Carbide Secured Registry. So what we've done at Rancher Government is we've actually built out an entire software pipeline to provide secured images, not only for the Carbide stack itself, but the entire supported Rancher product portfolio. Now, we've built these pipelines up to a SALSA level 3 compliance. SALSA stands for the supply chain levels of software artifacts. You can sort of think of that as the current industry standard when it comes to defining the security of that software supply chain. And what these pipelines are actually doing under the hood is they're scanning each individual image of each one of those products to produce things like a software bill of materials, also known as SBOMs, as well as vulnerability assessments. Now, for those of you who don't know what an SBOM is, you can think of an SBOM as essentially every component that goes into a piece of software. That includes things like the dependencies of the dependencies. And now that we have all those artifacts, the pipeline utilizes our secured signing key to do things like add attestations, as well as digitally sign each image along with those SBOMs and vulnerability assessments. And then we'll store those in our secured artifact registry that is hosted in Azure Government. Now, for our customers, they will get credentials to access that registry. And what that really does is that gives them that ability to do things like verify those digital signatures, verify those attestations of both the images, their SBOMs, and their scan results, utilizing our public key. And under the hood, really the benefit that that gives them is that provides provenance back to us at Rancher Government as the true owner, the true originator of those artifacts, and that we've attested to the contents of those artifacts. And the most powerful part about that is that those signatures can even be validated in challenging environments like in an air gap, since that public key is fully transferable. Now, beyond that, since we provided the SBOMs and the vulnerability assessments, our customers can then utilize those artifacts just to ensure that our tools meet their specific compliance requirements.
So a couple of questions. I wanted to just follow up on the idea of the public key used to look at those verifications of the attestations and of the signatures. The implication is that everything has to be secure, including what people say about the software security itself.
So in reality, everything that we're doing within the security world today has to be verifiable and has to be observable. So we're trying to put everything out there that can actually notate who built the software, where it was built, when it was built, and the vulnerability scans and the integrity of those scans at software creation. So by utilizing things like git sign, we're actually able, and what we do within Carbide is every single code commit that we do within the team is actually attaching our digital signature to verify that code commit back to us as a user. That way there is that chain of trust and that web of trust that can verify that those code commits actually came from the parties responsible within this organization. We want to make that as transparent, but more importantly, consumable to our customers. So as we were talking about earlier, you can provide that information all you want, but how does the user actually consume that? And how do they actually implement that within their security posture so they can get to production or to mission enablement quicker than ever? So we do that in every layer of what we do with Rancher Carbide, but we're also taking it a step further. That validation of the public key that can be done in air gap in an internet connected machine or even in low Earth orbit, we want to make that as prosperous as possible. So we've actually built in enforcement mechanisms on top of the Rancher stack that will actually verify that trust chain up and down the stack. And if at any point that trust is compromised, maybe a image doesn't match the digital signature that is represented in our public key, it can actually block that asset from running on top of the platform. We want automations to be at the core of everything that our customers do. And of course, security comes into play and should be number one in the automation landscape. So by not just releasing that information, providing the public key and the web of trust, what's really critical here is to implement the enforcement mechanisms to allow these computing platforms to scale, but with the security demanded by tomorrow's organizations.
And Adam, you mentioned verifying the dependencies of the dependencies in software. So the implication there is that not just the code itself, but the architecture and the internal operation of a bunch of code or an application is also part of the SBOM proof of goodness here.
Very much so. And that's one of the critical parts of this is the fact that our customers have that attestation back to us, and that we've gone and done our due diligence to validate and verify that all those pieces, all those components of the software is exactly as expected and what we've said it is. Now, as an industry, we're sort of at the forefront of what defines true supply chain security. You need to just keep iterating on it, right? This should be an iterative process. We should just continue to strive to be better and better day by day. And I think that's sort of where we're at as an industry and sort of where we're working towards.
All right. On that note, we're going to take a short break. My guests today are Brandon Gulla. He is the Vice President and Chief Technical Officer at Rancher Government Solutions, and Adam Toy is the Chief Architect for Rancher Government Solutions. I'm Tom Temin. This is Federal Insights, Securing the Software Supply Chain, sponsored by Rancher Government Solutions here on Federal News Network. Welcome back to Federal Insights, Securing the Software Supply Chain, sponsored by Rancher Government Solutions here on Federal News Network. My guests today are Adam Toy, the Chief Architect for Rancher Government Solutions, and Brandon Gulla, the Vice President and Chief Technology Officer at Rancher. I'm your moderator, Tom Temin. And let's talk about what happens after you have received software, your organization has received software. You have the bill of materials, software bill of materials, the SBOM, you have the attestations, you have Carbide to tell you this is all verifiable and it's going to be fine. But day 2, there's a patch. Day 3, there's a revision. And day 4, there's a new cybersecurity threat landscape. How does this all stay current after that day 1?
Yeah, great question. Thanks, Tom. So in reality, security is iterative and layered in every step of the journey. As we like to say that the secure supply chain is the beginning of the software security story, it's certainly not the end. And being that so many software packages have hundreds, thousands of dependencies, they're layered, much like the infrastructure that we see today. Operating system, Kubernetes environment, or container runtime, the applications on top of that. You have to have an inheritable security model all the way up and down the stack. In the legacy years, we've seen that with operating systems and software components where system administrators will need to rely on DISA or other standards to produce that secure technical implementation strategy, or what DISA likes to call a DISA STIG. So we've been fortunate enough to work with DISA over the past few years, and we are actually the only Kubernetes management software that has a DISA STIG hosted at disa.gov, as well as the only supported Kubernetes distribution having an active DISA STIG in our secure by default RKE2 Kubernetes distribution. So we believe in that standardized security and putting that up front in front of the users and giving that as a best practice of how to secure their cloud native baseline. But that only goes so far. We want to do more than just provide the best practices on paper. We want to give our users the observability and the monitoring capabilities that their downstream clusters and edge capabilities do not fall far from their security compliance baselines and standards. So what we've actually done is built a great tool called Stigatron. And Stigatron is exactly what it sounds like. It is the day 2 operator to ensure that security drift does not occur at your downrange environments. And you have the observability needed to ensure that your organizations are complying with the security standards of your assessors. So Stigatron is a great capability that we've built in-house. Adam, do you want to kind of elaborate on some of the capabilities and how users can use it?
Absolutely. I'd love to do that. So when it comes to a STIG and Stigatron specifically, what we really wanted to do with it was alleviate a lot of the pain points that come with traditionally validating that RKE2, specifically at runtime, is running in that truly secured manner. Now, traditionally, when you're going through those cyber assessments, there are a lot of manual steps that go into validating that compliance. And that's exactly why we built Stigatron. With Stigatron, we've automated real-time scans and analysis of your RKE2 clusters to ensure that it is always within those compliance guidelines of the STIG. Now, beyond just the scanning portion of it, it also provides a detailed look into each individual control of that STIG to give your administrators that critical feedback on what specific steps they would need to perform to get their clusters back into that compliance. Beyond that, it also gives you the ability to export those scans into the common formats that are used by both cyber assessors as well as the common cyber assessment systems that are out there, for example, ACAS and EMAS, to hopefully alleviate a lot of those manual processes that currently exist when assessing the runtime instantiation of RK2. Now, beyond just that part of it, we're always continuing to add capabilities to Stigatron. Soon we should have support to do runtime scanning of the Rancher cluster manager itself. We're also working towards customers being able to, for example, provide their own specifically tailored STIGs for their own specific requirements. So we continue to iterate on all of these capabilities just to make sure that they are sticking with sort of the standards as they grow.
And so one thing I do want to highlight, Tom, that what Adam said, and that was a key part of why we designed Stigatron. We don't want to be the exclusive security partner of these organizations. We want to be another asset in their security toolbox. And that's why we've built Stigatron to actually interface with these existing corporate infrastructure and scanning capabilities that are already in production and accredited by these organizations. So we can export directly as a STIG checklist file, directly to EMAS, directly to ACAS or Tenable. We don't want to be the sink in the story. We just want to be another step in the pipeline of proper security, no matter the organization.
And earlier you mentioned air-gapped instances. Sometimes in military situations, you might be operating on the edge and you're actually disconnected. Does that offer the opportunity or the danger of that security drift if something happens, some execution happens in the air-gapped environment, and then the next time you connect, you sync up and it's no longer air-gapped? Is that a danger point for security drift?
It is. And I'm really glad you bring that up, because in reality, everything we do here at Rancher Government is focused on the air-gapped customers. We've seen time and time again that air-gapped and disconnected customers are treated as second-class citizens in the software game. We see that as an opportunity because the US government demands the idempotency from going from maybe an unclassified to classified region. And of course, with everyone working over Zoom and at home now, you need to have the idempotency that you can build something in a coffee shop and it can exist and thrive in a government network as well. So that idempotency, especially when it comes to air gap, has to be there. But what you're touching on with the actual opportunity to compromise an asset in the field, that is something that both commercially and within the government community, we're seeing as a huge challenge with edge computing, right? Edge computing is the idea of moving away from the traditional data center and bringing the compute closer to the tactical environment, or the sensor, if you will. A lot of times these environments could be compromised, whether it's a warfighter, coming in and taking an asset, or maybe just intercepting it in the field. You need to have that awareness that up and down the stack, you haven't been compromised. So not so much within Carbide itself, but some of the ancillary tools that we provide here at SUSE actually work with the trusted platform modules within the hardware to ensure that the hashes and integrity of the computing layers up and down the stack are verified before a compute action can be taken. That's done both at the kernel level all the way up through Kubernetes. This is yet another tool in the security toolbox that we can help expose to the customer groups and allow them to pick and choose which assets they want to implement in their security posture from day 2 and beyond.
And you've described a lot of things that the Stigatron does and what the Rancher and the whole Kubernetes distribution itself does. It might be useful to talk about who's responsible for what in the context of supply chain security. There's a lot that agencies consuming software can demand of vendors, of people delivering software. So maybe divide the responsibilities here. What is, as the agency consumer, what do I have to make sure I do, and not simply accept, here's the SBOM, we're good to go?
Sure. I hate to be that guy, but security is the responsibility of everyone. And whether you're a developer, a practitioner, a system administrator, we all have to do our best to fortify the attack vectors that are presented to us and minimize those as well as we can. So we've seen that the government is providing different ways to inherit that security model. both, within STIG software such as ours, or even software build factories such as Platform One, Kessel Run, and of course, Platform One from the U.S. Air Force's trusted registry known as Iron Bank. They want to isolate the risk by providing verified trusted sources and scanned assets of software. So they want to extend that down to the end users. But even if an organization is using a secure build of a software package, they then still need to extend it and write their own code on top of it and follow security best practices. What's very important is to inherit from all those security best practices that have been done underneath of where that organization is in the stack, to ensure that they are adhering to those procedures, but also minimizing that attack surface up and down the stack. Adam, anything to add there?
Yeah, the one thing I always like to bring up in context of security, especially in context of potentially agencies, programs who are running these sensitive environments, is that they need to approach security as defense in depth, right? And that means that there needs to be this shared responsibility model against everybody, from the supply chain down to the infrastructure layer, down to the platform running on top of that infrastructure, down to the software itself. So I completely agree with Brandon that this is sort of a shared responsibility for everybody. And we will do our part, but everybody needs to do their part and make sure that they're configuring things the right way, setting things up and layering that security on at every level that they can, just to make sure that those assets, those sensitive data loads are truly secured.
All right. So maybe to summarize here, as a consumer of software from commercial sources, what should government agencies ensure that they are receiving besides code that is executable?
I think the security story starts in the supply chain, but that's not enough. And organizations need a reactive security model as well, whether it's through Stigatron, other security platform tools, to do that behavior anomaly tracking and monitoring on top of their stack. It's a two-part scenario. You can't just go with runtime. You can't just go with secure supply chain. It has to be the complete package to ensure that your organization is defending against modern attacks, because in reality, these attackers are moving just as fast, if not faster than we are.
Right. So you can't just simply say, here's the SBOM, we're good to go. You really have to know what's underneath the covers, so to speak, and understand those dependencies, and that the attestations and the SBOM itself came in a secure manner.
100%.
Okay, good place to end. Some really great thinking here on modern cybersecurity and that crucial idea of software supply chain security. We've been speaking with Brandon Gulla. He is the Vice President and Chief Technology Officer at Rancher Government Solutions, and Adam Toy is the Chief Architect for Rancher Government Solutions. I'm Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search Rancher Government Solutions.